I'm here to have the lecture on fluid pressure at a point, Pascal's law, and pressure variation in a fluid at rest. So let us start with the fluid pressure at a point. So what is the fluid pressure at a point? Consider a small area dA in a large mass of a fluid. That means if you have this large mass of a fluid, okay, now inside this large mass of fluid, we are going to consider a small area, and that small area we are going to represent by the dA. Let's say this is what the area of a large mass, and which is dA, which is dA. Fine. If the fluid is stationary, that means what? The fluid will be at rest, no motion. In short, fluid will not have any kind of the motion. The fluid at rest. That means this fluid pressure at rest, it comes under a portion of the fluid static. It comes under the portion or the part of the fluid static. In last previous lecture, we said that there are the three branches of the fluid mechanics. One is fluid static, the other is fluid kinematic, and the other is fluid kinematic or dynamic. Okay, fine. So this fluid pressure at a point falls under the fluid statics. Okay, and what is a fluid static? A branch of fluid mechanics in which we are dealing with the fluid, but condition is that the fluid must be at rest. So you see, fluid is stationary. Fine. If the force is exerted, if the force is exerted by the surrounding fluid on the area dA will always be perpendicular to the surface dA. Okay, the force exerted by surrounding fluid on the area dA will always be perpendicular to the surface dA. Okay, uh, let dF is the force acting on area dA normal to the normal direction. Okay, so dF is a force which is acting on this area dA, and the direction for this force is normal to dA. Okay, if I do have the ratio for this dF by dA, okay, then it is known as what? Intensity of pressure, or simply pressure, or the ratio represented by a P. That means this P, it can be intensity of pressure, it can be pressure. So this P, to have having the two names, it can be intensity of pressure or simply pressure. But I can write in mathematical formulae by this way. Remember, this dF is a small force, dA is a small area, and normal to each other. The F is acting in normal direction. Okay, that means what? You can see this pressure is a compressive in nature. This pressure, it is in compressive in nature. So we'll have, let's see, this is what surface. Now this is the direction of the force. Okay, so whatever the I shown, it is a force acting normal to this surface. This force is acting normal to this surface. Okay, fine. So if the force F is uniformly distributed over area A, then pressure at any point is given by F divided by A. That means if a number of areas, this dA can be divided into number of areas. Let's say this is 1 dA1, dA2, dA3, dA4, dA5, dA6, dA7. Likewise, I can distribute this mass of the fluid into number of areas. If I do have the over this area, number of areas, number of forces are acting. Is okay. If I do have the summation of this d all df and summation of all this dA, then I can write this intensity of pressure or simply pressure over the area by this one I've divided by A, where F is a force uniformly distributed over area capital A. You see, writing this expression, we use small df. Writing this expression, we use small dA. This is the intensity of pressure over a small area. Fine. And this is what intensity of pressure over the area. Now I can write the force or the pressure force that equal to product of intensity of pressure into area. Fine. So in this way I can write the term which is known as what, intensity of pressure or simply pressure for entire area. F is equal to A. If I am having the magnitude of what, PA, if I'm having the dimensions of the area, then I can calculate the force, and that is what, pressure force. This force or pressure force, I can write the product of P into capital A, where capital A is what? Capital A is entire area, P is intensity of pressure. Fine. So now let's see about the units. Okay. The SI units. The units of pressure are first kgf per meter square and kgf per centimeter square in MKS units. These are the MKS units. Second, it can be Newton per meter square or Newton per mm square. These are in SI unit. This Newton per meter square is known as a Pascal and represented by the PA. Represented by PA. Then commonly used units of pressure are kilopascal. That is nothing but 1000 Newton per meter square. Bar, that equal to 100 kilopascal, and that equal to 10 raised to 5 Newton per meter square. So in this way we seen the term pressure intensity. This is for a small area, this is for entire area, and the units, the MKS unit and the SI unit. Okay, and this term bar, 10 kilopascal, 100 kilopascal is known as a 1 bar, and that equal to 10 raised to 5 Newton per meter square. This Newton per meter square term is also known as a Pascal, and it is been written like this. So this is about a fluid pressure at a point. Fluid pressure at a point. Okay, you see, whenever the fluid comes in contact with the surface, that fluid will exert a pressure on that surface. To know the exact value of what the pressure force, we must have the value of the intensity of the pressure and the dimension of that surface. And what is the direction of the force to that surface? That direction of the force is normal to that surface. That means whenever I am talking about the pressure, that means it is in compressive in nature and it is towards the surface. That you have to understand. So this is one of the very basic concept about pressure at a point. Right? So whenever the fluid comes in your mind, that means it has a pressure. The fluid must have the pressure, and that fluid will exert a pressure when it comes in contact with the surface. If it is flowing freely, now you see the fluid is flowing freely, no resistance, so that fluid will not exert any kind of the pressure. As soon as, let's see, a plate is coming, vertical plate is coming in front of this flow, that fluid will exert a pressure over this surface. इसके सरफेस के ऊपर क्या करेगा वो फ्लूइड, प्रेशर एक्सर्ट करेगा. तो कितना प्रेशर एक्सर्ट करेगा ये हमें पता चलता है बाय दिस इक्वेशन. कितना प्रेशर एक्सर्ट करेगा ये पता जानने के लिए आपको लगेगी इंटेंसिटी ऑफ प्रेशर. एट द सेम टाइम यू मस्ट हैव द dimensions about the area. Okay, fine. So this is about the fluid pressure at a point. Next, is Pascal's law. Okay, so what the statement? Okay, so we have the derivation, the small derivation is there and statement is there. So statement, before let's see, statement, it says that intensity of pressure remains same in all directions. Okay, intensity of pressure, that is what P. Okay, in previous slide I explained about this one. So intensity of pressure remains same in all directions. So if I'm considering 3D, then intensity of pressure, this is in X direction. This is what intensity of pressure in Y direction. And this is what intensity of pressure in Z direction. Okay, that is nothing but intensity of pressure remain constant or equal in all directions. That is nothing but which law? Pascal's law. Okay, so if I do have a container of rectangular shape, and that container it has been filled with this much liquid. Okay, fine. And if I'm inserting a mobile, or you can say mobile is so costly, no one can dare to insert the mobile inside this container. Okay, it will get damaged. So the best way I'm having duster. Okay, if I immersed a duster here somewhere. Okay, and I'm saying, so the, let's say, the top area, the intensity acting in vertical downward direction, intensity acting in over the top area in X direction, intensity acting in this Z direction over the top area, it must be same. That is what Px equal to Py equal to Pz. Px equal to Py equal to Pz. That is the meaning. Okay, I hope everyone having the understanding about this statement. Okay, so let us have the derivation for this one. To have the derivation, what we have wedge shaped element. That element is triangular element. That element is what? Triangular element. Okay, and we shown the forces acting on surface AB, the forces acting on SC, forces acting on PC. Okay, so the or this AB force acting is Px dy into Px is what? Intensity of pressure. Okay, dy is what? Vertical length of that AB, and one is unit length, perpendicular. That means what? If I, this is the thing. Okay, so this is what AB, which is having the length dy, and B dash, A dash, it is 1. So in last previous slide we we're talking about this P is equal to what? dF divided by dA. So in this, what is the dA? dA, this one. What is the formula of dA? D is nothing but the area of the element. Okay, so dA is what? dy into bb dash कितनी है? 1. Okay, what is the intensity of pressure? The pressure exerting in horizontal x direction. So this is intensity of pressure is Px, compressive in nature, so towards the surface. Okay, so this is what the force exerting in x direction or the surface AB, force exerting in y direction or the surface AC, force exerting in z direction or the inclined face BC. Okay, so these are the forces. Now what we will do, we have the pressure forces, 1, 2, how many pressure forces are there? 3. Pressure force over the surface AB, A dash, B dash, pressure force over AC, C dash, A dash, pressure force over the inclined BC, B dash, C dash. Okay, so what is that pressure force? It is the intensity of pressure in x direction, area, it is dy into 1. Intensity of pressure in y direction, area dx length into 1. Intensity of pressure Pz, what? Yes, correct, ds into 1. Okay, so this is what about the all pressure forces acting on AB, AC, BC. Now next is what? Yes, correct, weight. Weight of the element in vertical y direction. What? Weight of the element in vertical y direction. Okay, हमने एलिमेंट कौन सी चूज की है? We selected the element of triangular shape. ठीक है, अब क्या करना है? Weight of the element. How to get the weight of element? So I must have, what is the unit for the weight of the element? Newton. Okay, if I take the product of rho g, okay, and then delta v, that is volume, then rho stands for the kg per meter cube, correct? G stands for meter per second square and v stands for volume, meter cube. So this product, it gives me the dimensions for the Newton. So what we will do, we will this one, the volume, we stand for the volume. Okay, the volume of the element. So instead of, to avoid the confusion, I like to write this as it is, rho g, volume. So okay, so volume, I'm writing the volume AB into AC divided by 2. Is it volume? No, it is the area of triangular element. Okay, into length, how much length this triangular element is have in perpendicular direction? It is 1. So this is a written volume, volume of the triangular wedge element. Okay, volume of the triangular wedge element. So this is what 2D. इसको 3D बनाएंगे हम लोग, तो एलिमेंट कैसे बनेगा वो, टू प्लॉट लाइक दिस. ठीक है, ये forget about this one. Okay, so this is what triangular wedge element. ये आपकी क्या है, triangular wedge element. This one, forget about this one. So this is what triangular wedge element. Fine. So but we to understand we have what 2D figure only. लेकिन 3D कैसी फिगर है, ये वाली. ओके, तो इसका वॉल्यूम बन गया ए बी इंटू ए सी डिवाइडेड बाई 2 इंटू 1. व्हाट इज द लेंथ ऑफ ए बी? ए बी की लेंथ कितनी है, डी वाई. ओके, ए सी की लेंथ कितनी है, डी एक्स. ओके, डिवाइडेड बाय 2. ओके, और इसको मल्टीप्लाई करेंगे हम लोग रो इंटू जी, रो इंटू जी. Okay, so this is what a pressure force, and this is weight is nothing but one kind of the force, and you know this weight is always acting in vertical downward direction. तो ये triangular wedge shape की element की weight क्या बनी है, इसकी volume of the triangular wedge shape element, उसकी density, और rho into g is nothing but what, specific weight. In short, if I want to have the weight of any material, then I must have its specific weight and volume of that material. इतना आपके पास होगा तो आपको मिल सकता है weight. So in this slide I return two forces, pressure force and the force due to the weight of the element. How many pressure forces I am having? I am having the 3 pressure forces, okay, that are acting on AB, AC and BC. Now with this forces, I'll go with what? I'll go with yes, fundamental of plane mechanics. प्लेन मैकेनिक्स में हम लोगों ने जो भी फंडामेंटल यूज किए हैं वो हम लोग अप्लाई करेंगे. ये हो गया आपका फ्लूइड के बारे में. प्रेशर टर्म आती है आपकी फ्लूइड के अंदर, है ना, यही एक टर्म फ्लूइड के अंदर लेके चल रहे हैं. हम लोगों ने लास्ट लेक्चर में देखे थे प्रॉपर्टीज ऑफ द फ्लूइड, तो वो एक प्रॉपर्टी हम लोग यूज कर रहे हैं. कौन सी प्रॉपर्टी? प्रेशर की प्रॉपर्टी. बाकी तो हमारी जो भी प्लेन मैकेनिक्स है, आप लोगों ने फर्स्ट ईयर में जो भी पढ़ा है वही हम लोग अभी यूज करने जा रहे हैं. तो कैसे यूज करते हैं देखिए. अभी हम लोग क्या करेंगे, फ्लूइड एट रेस्ट है, मतलब हम लोग क्या करेंगे, इक्विलिब्रियम कंडीशन यूज करेंगे. तो हम लोग क्या करेंगे, समेशन एफ एक्स समेशन एफ वाई, ये फंडामेंटल जो हम लोगों को पता है इसके बारे में वो यूज करेंगे. तो क्या कर रहे हैं देखो. तो आई एम राइटिंग द इक्वेशन resolving the forces in x direction. That means what? I am writing summation fx is equal to 0. I am writing summation fx is equal to what? 0. How I can write? So I have to write this one. I have to consider this one fx, and I have to resolve this force. So I have to take this component. Okay. So I am writing this one. I am writing this one. So this is what px into dy into 1 fine minus p, okay, ds. अरे बोलिए. Force in negative x direction, and I can write it here. Okay, so I am writing with minus sign p, the intensity of pressure, into ds into 1 sine 90 minus theta. That equal to 0. That equal to 0. So if I expand this bracket and I can you know this sine 90 minus theta I can write as a cos theta, the final expression I'll have like this. Okay, so px dy minus p into ds into what cos theta, that equal to what, 0. Now this px, this is what pz. Okay, so this is what pz. Now this ds cos theta, that equal to ab, and that equal to what, this dy. Is that okay? Okay, so ds cos theta, fine, that equal to what, ab, and that equal to dy. So finally I can write this px into dy minus pz into what, correct, dy, that equal to 0. Then I can write px is equal to pz. Px is equal to pz by doing the summation fx is equal to 0. Fine. So in the similar way, I can write the equation for summation fy is equal to 0. If I'm to have this one, I'll take this force in y direction, vertical upward. Then I'm going to resolve this one. So I'll have this force in vertical downward direction. In vertical downward direction. And by having the summation fy, I'll write, I'll get what, py dx minus pz dx is equal to 0. Py is equal to what, pz. Okay, so then summation fy if gives us py equal to pz, summation fx, we have what, px is equal to pz, correct. Now if I'm going to compare these two brackets, I definitely will write px is equal to what, py is equal to what, pz, and that is nothing but the Pascal's law statement, proof intensity of pressure remains the same in all directions. Okay, fine. So this is what about the Pascal's law derivation. Now next is what, the variation of pressure in a fluid at rest. Variation of pressure in a fluid at rest. Fine. So here I shown the element ABCD. Over the surface AB, the pressure force is Px into delta A. Over the DC, the pressure force is P plus del P by del Z into del Z into del A. Okay. So it has been said, why it has been written. We are saying that there is the intensity of pressure force or the magnitude of the pressure force is not same over this two surface. That means what? Uh, this is what pressure force acting over the surface AB. The pressure force acting over the surface PC. Okay, I'm not saying that the intensities are equal. Okay, if it is been equal and opposite, then it will get cancelled. So that's why I'm saying that pressure force is P into delta A over this surface, and it is greater. P delta A. Now it is having what? Force of equal magnitude, but we are saying it is greater. PA delta A plus. Kitna greater है? It is being greater by this much. Okay, incremental. Okay, getting this one? Okay, and length of this element is delta Z. Length of element is delta Z. And weight of the element. Okay, so we have the pressure force, this one, and weight of the element which will act in downward direction. How to get the weight of the element? The density of the element into G into volume of the element. Okay, into volume of the element, and that equal to what? Rho G, volume of the element, the area delta A into length of the element. What is that? Delta Z. So basically we have how many pressure? One force, that is pressure force is acting in downward direction on surface AB. Pressure force acting on in upward direction on DC, and third is the weight of the element, vertical downward direction. Now what we will do? Fluid at rest. So I'm going to have this one, summation Fy equilibrium condition, correct? Basics of fluid mechanics, plane mechanics. Summation Fy is equal to 0. Do this one. Okay. If I'm having summation Fy equal to 0, it gives me the pressure variation in fluid at rest. Let's see what is that. Let's see. Getting this one? Okay. Okay, that's I have here. The pressure force on AB, pressure force on CD, weight on the fluid element. Okay, now this things is about summation Fy is equal to 0 for the equilibrium fluid, the fluid at rest. And it gives me what? This final expression, delta P by del Z equal to rho G, and that equal to W. What? If this summation Fy is equal to 0, summation Fy equal to 0, it gives me delta P, that is intensity of pressure, delta Z, the, okay, this is what? A gradient. This is what? Gradient. In which direction? Z direction. Gradient of pressure in Z direction. That equal to what? Specific weight, rho G. Okay, and that rho G, it is nothing but a small w, specific weight. Okay, the fine. Now, what is the meaning of this one? State that rate of increase of pressure, rate of increase of pressure, that is del P, in vertical downward direction, that always equal to weight density of the fluid. That weight density is nothing but rho into G. That is a hydrostatic law. This is what known as a hydrostatic law. Hydrostatic law. Del P by del Z equal to rho G. Okay, this is what hydrostatic law. Okay, so that means what? Let's what is the application? If a container is there, inside this container, this much fluid is okay. I am having this much fluid. The height of the fluid, depth of the fluid in vertical downward direction is Z. So what is the intensity of pressure over this surface? हॉरिझॉन्टल सरफेस. कंटेनरचा हॉरिझॉन्टल सरफेस आहे ना, त्याच्यावर इंटेन्सिटी ऑफ प्रेशर किती असणार आहे? दॅट इक्वल टू रो जी झेड. I can get it by use of hydrostatic law. Very very useful. Vertical downward direction, rate of increase. म्हणजे डेप्थ झेड, आता हा झेड आहे, ठीक आहे, हा Z1 आहे. डेप्थ किती पाण्याची? Z1 आहे. सेकंड कंटेनर आहे, सेम साइज आहे. ओके, त्याची डेप्थ आधीची ही आहे. नवीन डेप्थ, वॉटरची डेप्थ किती आहे? द डेप्थ ऑफ वॉटर इज दिस वन. ओके, Z2. Now in this case, P1 equal to what? Rho G Z1. P2 is equal to what? Rho G Z2. Now you can see this Z1 is less than Z2. Therefore P1 is less than P2. Okay. So intensity of pressure is dependent on vertical height. ओके, और क्या किया, दोनों कंटेनर में एक ही फ्लूइड है, वाटर वाटर. ओके, द P is equal to what? Rho G Z. So P is directly proportional to the weight, specific weight, as well as Z. So getting this one, okay, this is all about hydrostatic law, one of the most important uh, derivation in fluid mechanics. And this hydrostatic law we are going to apply when surfaces are immersed. Okay, you can see the application in dams. Okay, dams, the reservoirs. Okay, the which are used for the storing the water. So in this pressure exerting over the vertical surface. Okay, pressure exert over the inclined surface. The surface is nothing but a gate which is being used for closing and opening or preventing the water flow. Okay, the vertical surface, inclined surface, or the curved surface. Curved surface. So you will find the application in next part of this unit. So today we covered the about the pressure. P is equal to, yes, for entire surface I can write F is equal to, I can summarize F by A. Then we seen that intensity of pressure remains the same in all direction. Px is equal to Py is equal to Pz. Okay, and hydrostatic law, that is rate of increase of pressure, del P by del Z is equal to rho G. So these three things we seen, and with this I'd like to conclude my lecture. Thank you for watching this video. Thank you.